Hello everyone and welcome to third tutorial. So let's start a little bit about theory. I will use a web browser and type Atmel MCU. Now in the Atmel company, if we go to the microcontrollers, we will start from the tiny series. We will get this page. So as you can see, the smallest MCU can have 6 pins, 3 from one side and 3 from the positive. So if we will start for something very simple construction, we will need to create an application which we will load in this chip. So what is actually happens? Let me draw one block diagram. So assume this is the chip. And it has 6 pins. And we want to do something with this microcontroller. For example, when we will press a button, for example, this is one button which will connect to this pin, and the other pin, it will be connected to the ground. So when we will connect this to this connection, this pin will be touched to ground. So when we will do that, we want, for example, from this pin open a light. We will put one resistor and then we will connect to the LED. So one pin will connect to the positive and the other one we will connect to the ground, to this pin. So this will be connected together. So when we will touch this, the light will be blink from this. Not blink, actually appear. Of course we can change later on to do blinking. But the first simple example is when we will press the button, just open the LED. If we release the button, we will not touch anymore the ground. Then the LED will be switched off. Okay? So in order to do that in microcontroller, we need to write some code. We can write it in assembly, ASM, or we can write it in the C language. We will start to learning assembly first, and then we will learn C. We will learn, as I say, 8-bit microcontrollers first. And we will start from the Atmel AVR family. When we will cover the assembly in Atmel AVR, we will move to the C example in Atmel AVR, and then we will move to the other company, microcontrollers, which is Cypress. And they have an 8-bit family which is called PSOC 1. In this microcontroller we will use C programming languages. When we will do that as well, we will move to 32-bit microcontrollers. 32-bit, which we call the ARM. We will use ARM actually. ARM Cortex M0, ARM Cortex M3, ARM Cortex M4. So now let's start with the assembly. In order to write something in assembly, we need to understand actually what we try to do in this chip. In this tutorial I will stop this lesson here because I want to show you something else first, just quickly in order to you to understand the whole process, what is happening. And then I will come back again here and we'll start explaining details why we do that. So let's start first something else. First we need to download the assembler. Of course we have in our after installation the AVR Studio 4.19 in our hard disk, in program files and in folder admin we will have AVR tools folder, and here we have assembler 2, and we have the older assembler which is AVR assembler. But there is also one open source assembler, very tiny, available on the web, and we need to download it and compile it. So let's do that. This assembly called AVR Avra. This is the home page. We will go to downloads and then to this link. Just do what I'm doing now. Even if you have some question why we do that, don't worry, just do it. Then we will click to the latest version, which is 1.3.0, and we will press to this file. Now in 3 seconds it will start the downloading. Okay, my free download manager is up here and request to download this file. I'm starting to download, so it's already finished. Now, because this file is in source code, we don't have already compiled binary, we need to download the C compiler for it. Very simple but powerful C compiler is PLSC for Windows. PLSC. We need to download this. So we will go to this page. We will go to the download and we will download the latest version, which is number 7. I have 32-bit platform, Windows XP, so I will download this file. Press OK. So my download manager starts to download this file also. And finally, I want to tell you to download one more software which we will use for reverse engineering, or for some cases where we lost our source code and we need to continue the development of our code. So this software is called ReAVR, and is available in this page. And if we go here, the latest version is 3.2. So press in this file and then press in download link. Now press OK, and this file is also downloaded. So now we have downloaded 3 files: the AVR assembler, the C compiler, and the ReAssembler. So let's use them. Now I will close the browser and go to my download folder. First I will install the C compiler, which is this one. So I will press on this, and now I have the Outpost firewall, which will ask me some question. Probably you will not have this message. So now you will continue in this window. I will press accept, next, next. Here Here I will choose normal installation, which is the standard C and window development. And press next. It will install in the program files PLSC. Install for all users. You can choose only for you, but I will install for all users. So our installation is complete successfully. Press close. Now what we need to do next, we have download this Avra file, which is compressed. We will press open to open it, and with our 7-zip extractor we will go inside, and actually here we will take the source code, which is this one. So we will extract this folder. Also we have this includes, we have examples and documents, but we don't need them. So let's select just these two folders and extract to downloads. Yeah, it's fine. So now I will press this one, and I can delete this file. I don't need anymore. So I will press here also close. Now I will create one more folder. I will call it Avra version 130, and then I will take these two folders and put inside it. So here in include I will not touch anything, I will left it as it is. In the source code I will delete these make files and these files, and I will leave only the source code. The source code is in pure C language, and it has many files and header files. So now we will take this source code and make them one executable. Okay, let's do that. Here now in the programs we installed the PLSC. So I will press the PLSC IDE. This is my firewall. Ask me permission. I will press allow. Now, in the first installation, you will have this pop-up window. So press the build. This will create, as it say above, the system definition database. Is used for the code completion of the symbols from standard include files. So in a few seconds it will finish the building of this database. If you have some question what I'm doing right now, because probably some of you are completely newbies in this area, don't worry. What I'm doing now is I'm using the C compiler, and I will try to compile the source code of the Avra project in order to get the binary file. In the next tutorials you will understand exactly what is that. So build complete and press close. So now in this program we will close everything, and we will create new project. From file, new project. We will create the we will create the pure Win32 console program. So we'll select this one. And then we will select the folder. I will select the folder which I already created, which was the Avra, this one. And I will call the project name Avra here. So do the same and press OK. So now here you need to put the source code. You will press on this name Avra and then press add files to project. Now in the pop-up window just go back and then go to the source folder. Then select all these files and press open. Now all the files is added to our project, and we need to compile it in order to get the avra.exe. So if I'm going to the Avra v130 in the Avra project, this file was already created from the PLSC program, which is this one, and in few seconds we will get the .exe file here as well. So in order to get that, we will need to compile it. But by default, if you try to build it, it will give you an error. You will see that. So press the build. Now I will press allow. This is from my firewall. And now in the building process, it says some warning. Don't worry about the warning, but it will get some error as well. You see, error 1. So there is some violation here. In order to fix this problem, we need to go to the options, actually not options, project options. Right, in the project options, compiler, and then remove the optimizing. So press none. Okay, and then because we have one more warning here, it's a unist std.h required -go compiler option. So in order to do that in the compiler option, we will go back project options, compiler, and here command line options, we need to add -go. We will press this click, define compatibility names, and it will appear here, and then press OK. So actually we done two things. We select the optimization to none, and we select this and press OK. And now if we press rebuild, we will have some warnings, but this warning is not a problem. And finally, allow, our project is compiled. So if you go here, you will see the avra.exe file. So actually this one is the file for our assembler. So we will use that. Now I will take this file, copy, and I will go to this folder and press it paste. Because here I have the include folders, which will be need for it. Now let's do one simple assembler programming program. I have very simple example in the folder. So I will take this file and put it in the Avra v130. If I open it with a simple text editor, you will have these 10 lines. Include The include line is defined for which microcontrollers we will use. This is for Atmel Mega 8 in this example. Of course, I will not explain you right now what I'm doing here. We will cover that in the next tutorial. The idea is that these lines is in assembly language completely, and this is real application. Actually, with this program, when you will power up the chip, you will get some high voltage in the port B. What is port B and what else, etc. Don't worry about now. Take the idea of how we compile the assembly language file to the binary file in order to load it to the chip. So write these things in your .1.asm file and compile it. So in order to compile it, I will go back and press in this folder. And if you remember, in the previous tutorial I told you to download the clicky program. You should have the Open MS-DOS prompt link here. So if you press it, it will open you the inside of this folder in the command line. So if I will press dir, I will get the content of this folder. And now if I will type avra, hello, okay, I will get this information from this AVR assembler. Okay, so in order for us to build this file, we need to write avra 1.asm, and we also need to give it some options. But I think it's not important. I think it will do it without even options. So press enter. Cannot find include. So I get an error here. So what? In order to fix this, we will open this file, and here we have two options actually. Take the this file and copy it to this folder, or we can take the name of this folder and put it here and say it like that. So the mdef, it will be available in includes folder. Close it and rerun our, let's clean the screen, and rerun our assembler. Okay, so actually look what happened in the background. It generates 1.conf, 1.hex for the EEPROM, 1.hex for the flash memory, and the object file. Why I like this very simple assembler? Because if you don't need the simulation of the and debugging of the AVR Studio, you can do your simple job in this Avra assembler microcontroller tool. Okay, so what happened right now? We create very tiny assembler program for the Atmel M8 microcontroller, and this is our source code. In order to put it in the chip inside, we need to assembler it. So we use that assembler, avra.exe, and generate this .hex file. Okay? Now this hex file and this file as well for the EEPROM, if we have some program for the EEPROM, we will load to our chip. If we open the, for example, Pony Pro and select the family, AVR Micro, and then select here Mega 8, and then if we press to open the file and go to our project, press the hex and select the 1.hex file, you will see that our program in memory is just this line. Very tiny, right? And here, if we connect our hardware to microcontroller and press the programming, this one, it will write the program to the chip. And if we power it, this chip, it will start to do that application. Okay, so I hope you understand right now what actually happens with our assembly process. When we create some program in assembly language, it can be from 10 lines or less to 100 or 1,000 lines, okay? This file needs to be assembled. So in order to do that, you need to use assembler. You can use the assembler of the AVR Studio, and or you can use the assembler of the Avra project. If you will use the assembler of Avra project, because this project was provided in the pure source code, you need to create the binary file. The binary file is this .exe. We created it with the Payless C compiler, as I showed you before. Okay. Now, let's do the final presentation of the ReAVR program. And we have this program here. I will extract the file from it and delete this file. And now I will press the installation. Press next, accept, next. Now it will install to this folder. Press next. I don't like this name, so I will put ReAVR 3.2. Press next. Select the additional task you would like setup to perform when installing the create centrally. No, I don't need this one. And press next. Install. So finally we create this tool. Finish. Now, why we need this tool? As I mentioned before, sometimes we can create some projects and maybe we can lose our source code, which is this one. But we can have the microcontroller, and we can, if we don't protect the microcontroller, we can read the flash memory, and it will give us from the programmer, if we read the memory of the microcontroller, like for example, we will press this button, read, it will give us the file with its contents. And if we save it, it will be .hex file. So if we open it with a simple editor, like I will press and I will open it with my Freeware hexadecimal editor, you will see the content inside of it. Actually, this is in the hexadecimal and is not readable, and this is not the source code as we want. So in order to see it as something similar to this file, we will do this trick. We will go to this program, ReAVR 3.2. Now, in this program, it asks us for the hex file. If we go to this folder where we have this hex file, 1.hex, and select it to open, you see that is automatically reassembly it. So now let's go to see what happened here. Our code is look like that. ReAssembly to start. Let's open this ReAssembly file as well, okay, and compare it. So it starts with ReAssembly, which is this one, and it go to the label 01, which is ReAssembly to this main. Don't worry, the names here of course is loose because is not stored anywhere, the name of the label. So in the reassembler it put automatically starting from L and then put some numbers. So now here in 0001 we have the LDI R16 KFFF. So what is the KFFF? Actually the KFFF here, it was declared like 0FFF. True, this is 0FFF because this is constant, I would say. Now let's continue. It put out DDRB, so it put out P17. P17 is 017. What is that actually? This information is available in this file .inc. Now if we go in includes in M16 and press open it, actually my Visual Studio is opening now. Let me close it and open it with different editor. Open with Notepad. Now here I will try to find this DDRB. You see, the DDRB is 017. Okay, so now you understand what's happened. And so actually this is 017, 0x17, comma R16, which is our register. So finally we have another one label loop and we call ReAssembly loop. So actually we loop. So we have ReAssembly loop to this loop, and that's it. So as you see, the reassembler reconstruct our binary hex file to our source code. So remember, this can be very useful sometimes for you, okay? So let's close this one, save no, and let's close this one. So in this tutorial, to summarize what we done, we download 3 programs. One was the C compiler. We will use it also for our next examples when we will do project in C language. We download the ReAssembly in order to construct our hexadecimal binary code to the assembly language. And we also download the Avra source code and create the executable from it in order to assembling our source code to our hex file. Also, I show you as well how to use the ponyprog. Now, in next tutorial, we will dive deeper in theory, because probably as you understand that with all what I show you now, you feel not confident about actually what happened. And we will cover in next tutorial, step by step, all these gaps. So thank you for watching and see you next tutorial. Bye.